Alright, so we're going to do some optimization. So the idea is that we have some constraints and we want to optimize a variable. So for example, let's say that you are a farmer and you go into your shed and you see that you have 200 feet of fence. Ooh. Alright, so you've got some fencing and you want to you know, contain some vegetables or I don't know, maybe some cows, and so you want to maximize your area. Okay, so let me show you a picture of what I mean. We've got this guy right here, so this is your barn, and then this is your fencing. Now so again, you don't need a fence along your barn wall, so you're using that as that side of the fence. This is the bird's eye view. Here's your tractor, and let's not worry about this for right now, but I do want you to take a look at this guy, the area right here. As we move the slider, you want to take a look at how that area moves, because we're trying to maximize that. So here we've got you know, this side which is labeled X is 0, and then this side is 200. Obviously the area is 0. That's like if you just plop the fence along the side, and notice that as you increase the length here of this one, your area goes up. But there reaches a point where the area is increasing, and then all of a sudden the area starts going down. So it starts getting really skinny up until the point where it's exactly, you've got both 100-foot length sides, and they're just stuck to each other, so the area is nothing. So that's the idea. Now the question is, well, how do we actually find that, right? I mean, how do we get this picture and actually calculate it? So that's what we're going to do right now. So we have 200 feet of fence, and then we have the also the barn. So let's write that down. The barn is, so the barn is 200 feet long. Okay, so that's my information. So let me write down some steps for you guys. We'll put them down. We'll put them down right here. Let me do. Okay, so we're going to write down the steps right here. The first thing you want to do is you want to, let me go a little brighter. Let's do some mocha. Okay, the first thing you're going to do is you're going to draw a picture. Draw a picture, and you're going to label. Okay, so here we've got a barn. So let me let's say that this is our barn. So I'm just going to do, obviously you can see that my drawing skills are not very good, but this is our barn. I'll label it barn. Okay, and then on this barn we're going to have the fence. So let me just say, you know, make it look something like this. And so let's label the sides of the barn something. So how about we label let's label this side right here X, and so obviously this side's going to also be X. And then let's label this side Y. Okay, so now that we've labeled everything, we're going to go on to the second step. The second step is a very important step. You need to find a formula for the quantity, whatever it is that you're trying to maximize. That's what you want to find your formula for. For formula for what is being optimized. Okay, so we're going to, since we want to maximize the area, that's what we're trying to optimize. So what we're trying to do is we want to find a formula for the area of this container. So that shouldn't be too difficult to come up with. Well, it's just length times width, so x times y. Okay. So this is, let me label this is step 1, this is step 2. Once we have that, we want to notice how what we want to do is we want to maximize the area, but the issue is that I've got two variables here. So, well, how do I turn that into an equation for one variable? So basically what you do is you're going to use your constraint. So you're constrained by something always, and you're going to use that constraint to write your formula in terms of one variable. Okay, so what's our constraint here? Well, our limitation, you know, it's very easy to see. Well, we only have 200 feet of fencing. So if we only have 200 feet of fencing, well, what does that 200 feet represent? Well, if to get to 200 feet, I would have to add up this guy, and this guy, because that's basically the amount of fence that I have. So I would basically add up 2x plus y. And so then I can use this to solve for one of the variables. So here, for example, let's say I'm going to solve for y. So y is going to equal to 200 minus 2x. And so then what you can do is you can basically grab this guy, plug it back into your formula from the area, and so then you have a new formula for the area. The area is simply equal to x times 200 minus 2x. Okay, which means that the area is equal to 200x minus 2x squared. And then the very last step is to optimize. Okay, so to optimize, basically what you're looking for once you have your formula is, for this guy, you're looking for the, depending on whether you're trying to find the maximum or minimum, you're basically looking for the absolute, in this case, maximum. Okay, so we already know how to do that. Remember, all you got to do is you got to find the derivative. Let's do it in, how about a different color? How about strawberry? All right, so the derivative is 200 minus 4x. And so if you solve for this guy, you would get that x is equal to 50. And so what you're basically looking for is the, so this is your critical point. Since you're looking for the absolute maximum, remember what you do is you plug in the critical points, which is 50, into the original function, and you plug in the endpoints. Now, the endpoints, you don't really have to plug them in, but in this case anyways, you sometimes do. But in this case, for example, remember this represents x, so the smallest x could be is 0, and the biggest x can be is 100. Let me show you guys why. Okay, so remember the smallest x can be is 0, but then that means that, so y would equal to 200, and so you wouldn't have any area. And then that's the same for on the other end of the spectrum. If x is 100, then you've got both of them stuck together, and again the area is nothing. So the area for this guy is for the endpoints is 0. This one is 0, and then for 50, let's go back. The area is right here, so it's going to be 50 times 200 minus 2 times 50, which is, so 200 minus 100 is 100, so 100 times 50 is 5,000. And so that's it. That's the maximum area, 500 square feet. And that's the basic idea for all of the optimization problems. And then let's go back and see, so let's make x equal to 50. Let's take a look right there, see? This is that's the spot right there, 50, that's the maximum. And so the area, this right here, this upside down parabola, this is basically the area function that you created down. And one last thing, I've got the links to several other optimization problems like this. For example, there's this one, maximizing the surface area of a cylinder with a fixed volume. And so you can play around with these and try to solve them. We've also got the maximizing the area of a rectangle with a fixed perimeter, and this guy minimizing the area of two shapes, which is pretty interesting. So you can play around with these. You just need the Mathematica player, which is free, and so you can play around with all those. And then there's all the examples on the other videos that I've got as well.